Alright, hello everyone. Welcome back to another lovely tutorial class, which is in mathematics. Today we are looking at a very lovely topic in this mathematics, and it is basically from coordinate geometry, which is equation of a straight line. How do we resolve equation of a particular straight line? Now, when an equation or a polynomial equation has a degree to 1, we call that equation of a straight line, which is the highest power of the unknown. That place will be 1. So that equation will be to degree 1. So the equation of a straight line has the following definition as y is equal to mx plus c. Now we are going to define the terms now so that you see what they actually means. Now before I go for terms definition, the first thing I'm going to do for me now, you are going to ensure you don't distract yourself by any means. Watch this video from the beginning to the end. Don't distract yourself by any means, and please ensure you also try your best to share this video to others. Subscribe if you have not done so. So thank you for doing that, and let's go to what we have today. Now, we said the equation of a straight line is defined as y is equal to mx plus c, depending on where you are taking the equation from. Also having it in which x now becomes the subject of the formula and so on. But ensure that if we are going to call it the equation of a straight line, the highest power of these unknowns there should be to degree 1. That is why c should be take note of. Now what is x? X is the horizontal axis, or we call it the axis sign in physics, practical physics, and y is the vertical axis we call the objects. Now in mathematics we call this one the horizontal axis, then we call this other one the vertical axis. So this is the y axis and this is the x axis. You can see the x and y axis. And which one is m? M is called the gradient or slope of this equation. The gradient or slope of this equation. So you take note of that. And what is c? C is actually the place in which this equation cuts this y-axis, which is the y-intercept. Yeah, we call it the y-intercept. And if x is such a formula, it will be vice versa. So this is the intercept, this is the slope, and this is the y-axis and the x-axis. Now I'm going to call equations of a straight line now. We can have equations of a straight line in which, listen to what we are going to be doing today. Now we have equations of two straight lines that are parallel to each other, equations of two straight lines that are perpendicular to each other. We have a way of calculating their equations. We have equation of a straight line in which the intercept will not be known, but the gradient will be known. We have equation of a straight line in which the gradient will not be known, the intercept will not be known. We still be able to calculate the equation of that straight line. So take note of this following I'll be explaining now. The equation of a straight line with a known intercept and gradient is defined as y is equal to mx plus c. This is the general definition of the equation of a straight line, where m is the slope and c is the y-intercept. While the equation of a straight line, two intercept is not known, but passes through a given point, a given known point. Say x1, y1. Say x1, y1. And passes through a given point. Say x1, y1. What is this equation of a straight line? Let's say, before I move to this next one, let me just give you an example of this. Okay, let's example. It's very good if we do just example. Let's example of this. Obtain the equation of a line, of a straight line. Obtain the equation of a straight line whose slope is 5. Whose slope is equal to 5. Obtain the equation of a straight line whose slope is equal to 5. Having an intercept that is 3. Having an intercept equal to 3. So we have the equation. We said the slope m is equal to 5. The intercept is equal to 3. So the equation now will be y is equal to m. M is 5. then c is 3. That will be the equation. Y is equal to 5s plus 3. That is all. So this one is very simple. Now let's go back to this now. Let's go back to this. Now, to obtain the equation of a line, that passes through a given node point, say x1, y1, that passes through a given point, say x1, y1, is defined as y minus y1 equal to m bracket x minus x1. Is defined as what? Y minus y1 equal to m bracket x minus x1, where m is the slope, y1 and x1 are the given node points. Example, let's do an example now. Example for this, I just mentioned. Example for this. Obtain the equation of a straight line. Obtain the equation of a straight line. Obtain the equation of a straight line whose gradient is equal to 2. Whose gradient is equal to 2 that passes through a given point. That passes through a given point, which is 1, 2. That passes through a given point, that is 1, 2. Calculate the equation of a line, a straight line, having a gradient equal to 2, that passes through a given point, 1, 2. So how do we do this? They say the gradient, which is slope, is 2, and the points x1 and y1. You have 1, 2. We say the points are always x, y. So this first one will be the x, the second one will be the y. This is always built from s, y. If we have the third one, which is not in our space, it will become z again. So it's always in the form of s, y. So the s is 1, the y is 2. So go back to this place. Remember, if you want to calculate the equation of a straight line that passes through a given node point, just one point, whose gradient is known, we use this relation, we use this model. Is this? So therefore, the equation will be y minus y1 is what? 2 equal to m bracket x minus x1 is 1. So from there, let's solve everything. We're going to have y minus 2. 2 times x, we're going to have 2x. 2 times 1, we're going to have 2. Then we have y is equals to 2x. We move on to this side, we're going to have minus 2. If this one point is we're going to have plus 2. Therefore, we have y is equal to 2x. Minus 2 plus 2 is 0. So y will be equal to what? 2x. That will be the equation. We can also say y minus 2x is equal to 0. Which can also be the equation. That is, we move everything to one side and equate it to 0. Also have the equation that is simple as ABC. Now let's look at another question under this. Look at another question under this. Find the equation of a straight line. 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 Find the equation of a straight line that passes through a given point 1, 1. That passes through a given point 1, 1. Having a gradient of minus 3. Having a gradient is equal to minus 3. If the gradient is minus 3, what will be the equation of this straight line? Passes through this point. So our gradient n is minus 3 on our x1 is equal to 1, y1 is equal to 1, s, y. So our equation of a straight line that passes through just one given point with a no gradient is y minus y1 is 1, then minus 3 bracket x minus x1 is 1. So we're going to have y minus 1. This one times is going to have minus 3x. Another times is going to have plus 3 times 1 we're going to have 3. Then we're going to have if you move this one to the other side, you're going to have minus 3x, then plus 3. If this one become plus 1, I mean y is equals to minus 3x plus 4. So that's going to have, that is minus 3x times x, we have this. Minus 3x times minus 1, we have plus 3x. Minus is going to give us plus. So next I'm going to have going to be y plus 3x is equal, okay? Look at it, there's no need of doing that first. Look at this could be the answer set. That can be the answer to the question. Or you also say y, move everything to one side, plus 3x minus 4 equal to 0. This one can also be the answer. So this and this are correct. They are the equation of this straight line. So you take note of that. It's very, very important. So let's look at one more question. Obtain the equation of a straight line. Obtain the equation of a straight line that passes through a given point 2, 3. Obtain the equation of a straight line that passes through a given point 2, 3. Whose gradient is equal to 1. Obtain the equation of a straight line that passes through a given point 2, 3. Whose gradient is equal to what? 1. So how am I going to do that? The gradient is equal to 1. And the points, we have x, y. So our x1 is equal to 2, y1 is equal to 3. So from this equation, the straight line that passes through a given point, we have y minus y1, y is equal to 3. So equal to x, that's n is 1, x minus s1 is equal to 2. Now give us y minus 3 is equal to 1. 1 times s now give us 1x. 1 times minus 2 now give us minus 2. So y will now equal to, if you move minus 2 to the other side, we have x minus 2, x minus 3 goes to this side, come plus 3. If you now go to this other side, this minus will change to plus. So we have y is equals to x minus 2 plus 3, or 3 minus 2. So that is a 3 minus 2, or minus 2 plus 3. What are you have? We have plus 1. So this will be the equation. We can also say y minus x minus 1 is equal to 0. You don't have to use that minus s. Plus 1 plus this minus 1. This will also be the equation of the straight line. So this is how we calculate the equation of the straight line that passes through a given point having a known gradient. Now, the one we want to look at now, we want to look at the equation of a straight line that is parallel to another line, but it passes through a given point. Equation of a straight line parallel to another line, and it passes through a given point. So let's add that equation now to see how we are going to unravel that mystery. But remember that equation of a straight line is always this one. Y is equals to ms plus c. Check everything we have the axis. Check this one. Y is equals to ms plus c. Our m is greater than x minus 3. Then check this other one. Y is equals to ms plus c. Greater than 2, that is 0. Then what about this? Y is equals to x plus 1. Greater than 1, that is 1. This one is 4. That one is 3. Then the gradient is 5 on this, and so on. So you can also indicate the gradient out of an equation that way. So let's look at now equation of the line, either perpendicular to a particular line or parallel to another line. That's the next one we're going to look at now. So stay with us. Alright, let's do. Now, parallel and perpendicular lines. Parallel and perpendicular lines. Now, you write, if two lines are parallel to each other, if two lines are parallel to each other, comma, if two lines they are parallel to each other, comma, their gradients will be related as follows. M1 will be equal to M2. M1 will be equal to M2. Where M1 is the gradient of the first line, M2 is the gradient of the second one. So what am I trying to say? I'm trying to tell you that if two lines are parallel to each other, their gradient will be the same. Their gradient will be what? The same. Gradient will be the same thing. So take note of that too. If two lines are parallel to each other, their gradients will be the same. Their gradient will be the same. So we have the same gradient. The gradient of the first one is equal to the gradient of the second line. While for two perpendicular lines, while for two perpendicular lines, like if two lines are perpendicular, two straight lines are perpendicular, comma, their gradients will be related as follows. M1, M2 equal to minus 1. M1 and M2 will be equal to minus 1. So for two perpendicular lines, if you multiply their gradients, it will be equal to minus 1. Ignore that. Or M1 will be equal to minus 1 over M2. Or M2 will be equal to minus 1 over M1. Ignore that. So this one is for perpendicular lines. So if you want to make M1 equal formula, divide both sides by M2. You have this. If you want to make M2 equal formula, divide both sides by M1. You have this. So that's this one is for two perpendicular lines. Why this is for parallel lines. Parallel I don't have any issues. Perpendicular line I have a major issue here. Now let's look at a very good question now. Look at a very good question. Okay? Obtain the equation of a straight line. Obtain the equation of a straight line. Obtain the equation of a straight line. Obtain the equation of a straight line that is perpendicular to the line y is equals to 3x plus 4. That is perpendicular to the line y is equal to 3x plus 4. That is perpendicular to the line y is equal to 3x plus 4. Obtain the equation of a particular straight line perpendicular to another line y is equals to 3x plus 4. This is the equation of the line, that line is perpendicular to 3x plus 4, comma, and passes through the points, 1, 2, and passes through the points 1, 2. So let us obtain the equation of the straight line that is perpendicular to this line now. This equation of the line, this line, particular line is perpendicular to, and this line passing through this point. So let's obtain the equation of this line now. Remember, for two perpendicular lines, their gradients will be related in this manner. So what is the gradient of this first one? What is the gradient of this one? That's what I'm going to look at. What is the gradient of that line? We already know that our S1 is equal to what? What is S1 here? S1 is what? S1 is 1 and then Y1 is what? 2. This one is S, Y. Remember, equation of a line that passes through one point to a given point. Then with a known gradient. Now we are going to check on the gradient of this particular line. But what is the gradient of this line? This one. The gradient is not particular to this. So we have y is equal to ms. So you compare this one now to y is equal to ms plus c. So compare this to this. Let's check for the gradient. We have y is equal to 3x plus 4. Then combine it to y is equal to mx plus c. That is first thing. Or to get the gradient, you can also say y is equal to y, n is equal to x, m is equal to 3, c is equal to 4. So gradient will be equal to 3. Gradient is equal to 3. Which is gradient of x equal to gradient of x. This is the first way to do it. Another way to get the gradient is to differentiate the equation once. There's another way to get gradient. Differentiate the equation once. If you also differentiate the equation once, you also get gradients. So let's differentiate it now. Differentiate this one related to x. We're going to have differentiate 4, 0. Differentiate 3x, you have 3. This one is also called gradients. Also, you see, gradient m is 3. You do it from comparison. You also differentiate this. You also have 3 gradients. You are very correct. Now, is that the gradient we are going to use? No. They said the line we are talking about is perpendicular to this one, whose gradient is 3. So therefore, you now say, okay, for two perpendicular lines now, their gradients will be related as follows. Therefore, our m1 times the m2 will become what? Minus 1. m1 times m2 will be equal to minus 1. Then we can now say that our gradients to be used in this particular question now will be, let's go. The gradient of this one is 3. So you put it 3 here. That's a 3 times m1. Or we just say, the gradient of this particular one is m2 will be the gradient of the first line 1 over the gradient of this line we have in here. So therefore, since they are particular, the gradient to be used will be 1 minus 1 over the gradient of this line. So this is the gradient we are going to use now. Why are we using this gradient? Because the line we are talking about this question is perpendicular to this. So anything that's perpendicular, they are gradient to be related in this manner, which is m2 is equal to minus 1 over m1. So we are looking for this line at m2. When you know this m1, we'll take minus 1 over that, and so on. That's how we do it. So this is the gradient I'm going to use. Remember, we call that for equation of a line that passes through a given point with a node gradient is given by y minus y1 equals to m bracket what? S minus s1. So therefore we have y minus, what is y1? y1 is 2 over minus 1 over 3, that is the m, over s1 is what? That is s minus 1. That's going to give us y minus 2 is equals to, this one times this, we will have minus x over 3 minus x1, is plus 1 over 3. Because this one times 1 is only the same thing. The next thing I'm going to do, since the denominator, you check, what is the highest denominator here? The highest denominator is 3. So I'm going to multiply everything with 3. I'm using this to multiply everything through. So that this denominator will go. I want to multiply everything with 3. Y times 3, we have 3y. Then 2 times 3, we have 6. Minus x over 3 times 3, that will give us minus x. 3 will cancel 3. Then, what I'm going to say, I'm going to multiply everything with 3. So 3 times this, that will be 3y. 3 times 2, that will be 6. 3 times this one, 3 will cancel 3. That will be minus s. 3 times this, 3 will cancel 6. And then 1 will be left out, plus 1. So I'm going to have 3y is equals to minus x plus 1. If minus 6 doesn't transfer, we have 1 plus 6. That will be 3y is equals to minus x plus 7. Minus x plus 7. That's what I'm going to have. So I'm going to have. Then at the end of the day, we can move it to one side. We're going to have 3y plus x minus 7. So this is another going to be line, or that will be the equation to that line. So please ensure you understand what just transpired here. It's trying to get it. What we said was obtain the equation of a line perpendicular to this line. So what you do, you get the gradient of this line by differentiating this equation or comparing this equation to this. Anyone you like to do it. So that you differentiate this or you compare it, the equation to this, just do comparison. Then use this relationship to get the gradient of this question. Since it's perpendicular to this, so you have this. Next, use this one because any line that passes through just one point with a node gradient, you can use this equation to get the you can use this formula to get the equation of that line as far as it's a straight line. The next, then you have this, you're going to have your answer. So please, let's look at another question. Look at another question to see what we're going to have. Alright, find the equation of a straight line. Find the equation of a straight line. Find the equation of a straight line which is perpendicular to the line 2x plus 3y minus 1 equal to 0. Which is perpendicular to the line 2x plus 3y minus 1 equal to 0 and passes through a given point 4, 3. And passes through a given point 4, 3. Now we have to find the equation of the straight line now. Find the equation of the straight line that is perpendicular to this particular line. Perpendicular to this particular line. Line is perpendicular to this and passes through this point. So that's what I'm going to do. Remember steps. First you get the gradient of this line, then use this relation to get the gradient of the second line we're looking for. Then use this equation, this relation to get the equation of that line. First step, you get four perpendicular lines, parallel for perpendicular lines. First step, get the equation of the line in question, which this line is perpendicular to. Second step, use this equation to get the slope of this perpendicular line, which is perpendicular to this. The third step, use this relation to get the equation of this straight line. That is all. For this now, our S1 is equal to 4, Y1 is equal to 3. That is simple enough now. The next thing, to get this gradient, is either you compare this to this or you differentiate this one. And we check on this one is an implicit function, which both x and y are expressed together, and there's no defined subjects of this formula. So to get this one, we just say the y over dx is equals to, which is the gradient. Therefore, differentiate minus dx dx over dy. Remember from infinite function in calculus. Then the next thing I'm going to do, differentiate everything related to us. Differentiate this one, I'm going to have 2. Differentiate this one, that's 0, there's no s here. Differentiate this one is 0, but there's no s there. Over, differentiate related to y, differentiate this one, no y, 0. Differentiate this one, I'm going to have 3. Then differentiate this one, I'm going to have 0. So I'm going to have minus 2 over 3. That's going to be the equation, that's going to be the gradient of this line. So that is the over dx from implicit differentiation we did in calculus. If you don't know how to do implicit function, you can go back to our videos. It's here, it's there. Just check for implicit function or full topics in calculus. It's there, live. Or if you don't want to do the gradient this way, the next thing is to make the other way to do it is to make y subject to the formula and compare this to this. So now we make y subject formula, you can do it, you can do it. How do you do it? Move s and the other one to the other side. You have 3y is equals to move s to the other side minus 2y, because if this expression is become minus, then move 1 plus 1. Next thing, divide 1 by 3, divide here by 3. So we cancel this. Y will be equal to we have minus 2x divided by 3 plus 1 divided by 3. That's what I'm going to have. That's what I'm going to have. The next thing will be to compare this to y is equals to mx plus c. So we compare this and this now. Our y is equal to y, s is equal to x. Then m will be equal to what? What is the m here? M will be equal to minus 2 over what? Over 3. You see this. 1 over 3. Then what is intercept? Intercept is what? Intercept will be 1 over 3. We don't even need this one in our equation now. We don't need that stop here. So that is intercept of this particular equation. That is an intercept. We don't need the intercept. Let's have to do comparison. So the next thing, remember, this is the gradient of this particular line. So what is the gradient of this one now? We are going to look at what is perpendicular to this one. The gradient of this second line we are looking at now will be minus 1 over the gradient of this first one, which is minus 1 over minus 2 over 3. Now, if you want to do minus 1 over minus 2 over 3, minus, you cancel minus. Then this denominator will go and multiply the 1 in the numerator. We're going to have 2, that's 3 times 1. 3 will go and multiply this. That's how to do it. Or you can just say 1 divided by 2 over 3. 1 times, you can take the inverse of this, 3 over 2. This is not like this, that's 3 over 2. Or you just use this 3 to multiply 1, you have 3 over 2. So the gradient of this 1, this is perpendicular to this now. This line, I'm looking at perpendicular to this is 3 over 2. So next step, the third step now, is to go to this formula and obtain the equation. We have y minus y1, y minus, what is y1? 3 is equal to x minus s1. But what is m first? M is 3 over 2 now. So that is the line I'm looking at perpendicular to this. The x minus, what is s1? S1 is 4. So that will be y minus 3 is equals to, what is this? 3s over 2 minus, what is this? That is 12 over 2. 12 over 2. And what is 12 over 2? 12 over 2 is what? 12 over 2 is 6. 12 over 2 is 6. So leave that one. So what the next I'm going to do now, we're going to multiply everything by 2. Because we're going to use 2 to multiply everything. We multiply everything with 2. Or if I want to simplify it, we have y is equals to 3x over 2 minus 6. Use and put this line to become plus 3. Okay, y is equals to 3x over 2. Then minus 6 plus 3, that is minus 3. So if you want to linearize the equation now and bring it back to this form, multiply everything by this 2, which is the highest denominator of all the terms present. So we have it, multiplying everything with 2. 2 times y, we have 2y. 2 times x, 2 times 3x over 2. 2 we cancel 2. Only 3x will be left. 2 times 3, that's minus 6. So that is what I'm going to have. So therefore, equation becomes y, that's equation is going to become something like this. 2y minus 3x plus 6 is equal to 0. This is going to be the equation. The 2x minus the equation can now be presented this form, or this form. Any form is very, very possible. It's possible. So 2y times 3x plus 6 is equal to 0. Because I want to try and bring the equation back to this form. That's what I'm trying to do. So now let's look at the equation of a straight line which is parallel to a line. Because we are doing perpendicular, so let's look at the parallel. for a case which is parallel and other aspects of this equation of a straight line before we go. Alright, let's look at this. Find the equation of a straight line. Find the equation of a straight line. Find the equation of a straight line which is parallel to the line 8x minus 2y minus 6 equal to 0. It's parallel to the line 8x minus 2y minus 6 equal to 0. And passes through the point 2, minus 1. And passes through the point 2, minus 1. So the line we are talking about is that it's parallel to this line. The line is parallel to this line. So how do we get the equation of this particular line now we're talking about? The first thing is to get the gradient of this line. The first step. So what is the gradient of this one? So to get gradient, it's either you differentiate it for a parameter, for something like an implicit function of this nature. Either you differentiate it or you compare. Just make y equal formula and you compare. So let's differentiate to see dy over dx will be, to differentiate this one, that is minus dx. You know that to x will be 8. Differentiate this one 0, differentiate this one 0 because there's no s there. Then over. Then differentiate the rest to y now. dy. Differentiate this one as 0. Differentiate this will have minus 2. Differentiate this will have 0. So this will give us, this over 2 is what? 4. This is the gradient of this line. Or another way to do it, you make y the subject of the formula. Make y the subject of the formula. So we have minus 2y will be equal to minus 8x plus 6. That's what we have. The next thing, you make y the subject of the formula. Minus 1, bring it to that side, move this to that side. Minus 2y, that's minus 2. Minus 2 by minus 2. The next thing, you are counting this. And y will now be equal to this into this, we will have 4x. Yeah? This into the will have minus 3. Because 6 divided by minus 3 will be minus 3. The next thing we are going to do here, compare this to this, compare this to y. It's equal to mx plus c. Our y is equal to y. And will be equal to 4 as well. You see as that. So either you don't differentiate to get the answer directly, or you start making y formula to compare to that stuff. So m is equal to this, intercept is equal to what? Minus 3. So the next thing, check. For two parallel lines, we said, recall that for two parallel lines, we said m1 will be equal to what? M2. Both of the gradients will be the same. So because this line is parallel to this now, the gradient M2 that you're going to use will be equal to this gradient we saw for this one. We see same thing as 4. Both the gradient will be the same thing. But for perpendicular line, it will be minus 1 over the gradient of this line, particular line. But for parallel, you still use the same gradient. The gradient will be what? We see. So the next thing, go back to the equation of that model. Y minus y1 equal to m bracket x minus what? S1. This is the last stage. This is the last stage now. This is the model for the formula or the relation used for to move the equation of the line to given node point and has the node gradient. So we have y minus what? Minus y1. What is y1? This means what is y1 here? y1 is equal to what? Minus 1. S1 is equal to what? 2. So y minus y1 is minus 1 is equal to m bracket x. What is x? 2 minus x1. What is x? S1 is what? 2. That will give us y minus minus plus 1 is equal to 4x minus 8. So this one will give us minus 8. Next, I'm going to do y will be equal to 4x minus 8 minus 1. Plus y is equal to what? Equal to 4x minus 9. So if you move it to one, this will be the equation. It's correct, very correct. That's what we move it to one side of this nature. We're going to have y minus 4x plus 9 is equal to 0. Movement, we have minus 4x minus 1 is become plus. So that is still very correct. So please and please and please and please and please ensure you follow. It's very important. Make sure you what? Follow. Follow everything. It's very important. So this is the line which is parallel to this, passes through this point. Now, lastly, we're going to look at the equation, the third one. Equation of a line remember we looked at equation of a line with a known intercept and gradient, equation of a line that passes through a given point and a known gradient if they are perpendicular and if they are parallel as well. Now we want to look at equation of a line that passes through two given known points. Two given what? Known points. Equation of a line that passes through two given known points. Let's look at that now. So, right. Furthermore, the equation of a line that passes through two given known points, is obtained, can be obtained by relation y minus y1 over y2 minus y1 equal to x minus x1 over x2 minus x1. So this relation we use want to obtain this particular equation. This equation of a straight line that passes through two given points. Right? What? Two given points with without any known gradient or intercept. Okay, let's do an example. Find the equation of a line. Find the equation of a line that passes through the point P 1, 1 and Q 3, 4. That passes through the points P, which is 1, 1 and Q 3, 4. That passes through two given known points. So for this kind of equation that passes through two given known points, we are going to use this relation to unravel the mystery. Now, which one is the S1? Which one is the S2? Which one is the S3? Which one is the S1? Which one is Y1, Y2, S1? So let's look at that. Now, look at it. The equation of a line that passes through two given node points. Look at the node point there. S1, Y1 and S2, Y2. This is how to give it. The equation of a line that passes through two given node points. S1, Y1 and S2, Y2 is given by this solution. So this first one here, this one is our X1, Y1, so that's our S2, Y2. If you take note of that, it's very, very important. In the first point, we have S1, Y1. Second one, we have S2, Y2. So our S1 is equal to 1, Y1 is equal to 1, S2 is equal to what? 3, Y2 is equal to 4. Take note of that. It's very, very important. So how do we obtain this equation now? Using this relation, we have Y minus Y1 plus 1. All over S2, all over Y2, what is Y2? 4 minus Y1 is equals to X minus Y1. S1 is 1. All over X2, S2 is 3, minus X1, which is what? Is 1. The next one we're going to have Y minus 1 is equal to, this one is 3, is equals to X minus 1, all over, which is what? Is 2. Next thing, I want to linearize the equation now. You are free to multiply. You are free. So 2 times y, that is 2y. 2 times minus 1, that is minus 2, is equal to 3 times s, that is 3x. Now we multiply this, so multiply this one, multiply this one. 3 times s, that is 3s. 3 times minus 1, that is minus 3. Next, move everything to one side and put it to 0. You have 2y minus 2 minus 3x. Or you can also do this way. I'll do this way. This is 2y, then s minus 3x before this one, minus 2. Then move it on now. Plus 3 equals to 0. We have 2y minus 3x. Then minus 2 plus 3. What is that? That is plus 1 equal to 0. This is the equation that passes through this point and this point. So please take note of that. How to solve that. The first thing, you mark out the points. Let's say use this relation to obtain the equation, which is y minus y1 over y minus y1 equal to s minus s1 by s1 and what? S1. So after you have substituted the values, next you are going to do, you find the equation from just normal calculations. So next you are going to look at all these and that's all. That's true. That's doing that. True that. So let's take everybody check whether what you are doing is in order. So you can another. Alright. Let's look at the last. Let's look at another question now. Look at another question, which will be our last question for today. Alright, last question. Find the equation of the straight line. Find the equation of the straight line that passes through points. Minus 5, 7 and 1, 3. That passes through points minus 5, 7 and 1, 3. So find the equation of this straight line now. That is all. So remember, S1. What is our S1 here? Minus 5. What about Y1? 7. What is S2? 1. What is Y2? 3. So S1, Y1, S2, Y2. You didn't know that. Very, very good. So from this relation now, we have Y minus Y1. What is Y1? 7. All over Y2, 3 minus Y1, 7 is equals to X minus X1. What is X1? Minus 5 over X2. What is X2? What is X2? 1 minus X1 is minus 5. That's all. That's all. The next thing we're going to have Y minus 7 all over minus 4 is equals to X minus plus 5 all over 1 plus 5. That will give us, what is 1 plus 5? 1 plus 5 is equal to what? 1 plus 2 to 6. I'll give us 6. Let's see multiply. This times this times this. Let's multiply. Let's see what we'll do now. We'll multiply. So we'll have 6 times y, that's 6y. That's 6y. Then 6 times 6, that's 36. So another that's 42. That's 42. So we're going to have 6 times 7 will be 42. Is equals to this minus 4 times s, that's minus 4x. Minus 4 times plus 5, that's minus 20. That's minus 20. Let's move it to one side. We have 6y. Then plus 4x. If this plus minus 4 is become plus, then minus 22. If this one is become plus 20, it's equal to 0. Be equal to 0. Next we're going to have will be 6y plus 4x. Okay, look at this. Minus 42 plus 20. That will be minus what? Minus 22. That's what we're going to do. It's equal to 0. So let's say if you get away with something is common between them, 2 is common. So you divide everything 2. This one can be the equation, this one can be correct, but something is common between them. So you divide this one by 2, you have 3y plus divided by 2, you have 2x, and divided by 2, 11. Divide 0 by 2, by 2, by 2, by 2, by 2. It should be 0. Because that's what I'm talking about. Still very, very important. So once you have 3y plus 2s minus 11 is equal to 0. Please ensure you know what you are doing here. Ensure you know the 3 equations we just did. First one is equation that have intercept and gradient. This y function ms. This is the equation of the straight line. So we now have one given point with no gradient. We use this relation. If we have 2 given points, with this relation. So you have 2 parallel lines, they are gradient will be the same, or 2 perpendicular lines, they are gradient by gradient of the first vector to minus 1 by gradient of the second line. So please ensure you watch this video over and over again, how to get the full gist by this class we just did. So please ensure you follow us up, ensure you support this channel by subscribing and sharing this video to others. Thank you, and watch it online over and over again. And you can always come here to watch your preferred mathematics topics. We have them here in this channel. Calculus, we have them here. Statistics, we have them. Normal algebras, we have them. Even physics, we have them here. So please and please, God bless you all as you follow us. God bless you all as you support this channel by sharing to others and telling others about this channel. Thank you. God bless you. I wish you a successful academic pursuit. God bless you. You all will be successful in your academics. Thank you. I love you. Thank you.